Firstly, let me commend the conference organisers, Weardale Lithium, for putting on what are really important conferences, and we're seeing them around the world and bringing these issues to the forefront of our industry. It's an interesting title, Future Resources. I started to address that at a conference in Riyadh earlier this year. For us, future resources are those critical raw materials that contain the strategic metals for transition, for decarbonisation to a clean energy future. And as a way of background, we see them as, yes, lithium, nickel, copper, cobalt, manganese, rare earth elements, and platinum group metals. To begin, EV Metals Group plc is a battery materials and technology company committed to a clean energy future. We are focused on the production of high purity chemicals and cathode active materials which are required for rechargeable batteries for electric vehicles and renewable energy storage. We offer a unique global business model and strategy. We're the first company, or the only company outside of China building, do I operate this? Here we go. We're the only company outside China building processing capacity for the production of cathode active materials based on upstream integration of supply chains for critical raw materials containing lithium, nickel, cobalt, manganese, and other metals. We will produce cathode active materials for electric vehicle and battery cell manufacturers in the UK, in Europe, and the Kingdom of Saudi Arabia, seeking long-term, transparent, and geopolitically aligned supply chains. So the illustration on the right-hand side of this slide is very simply showing that our business model is participation in the ownership, the mining and processing of mineral resources to produce intermediate products that are shipped to midstream processing capacity to produce high purity chemicals, and then those high purity chemicals are then taken into pre-cam and cathode active materials plants to produce the cathode active materials required for batteries for electric vehicles and renewable grid scale storage facilities. One of the things that I think is coming to the fore in the industry, and we've made observations over the last 12 to 18 months accordingly. If we look domestically at the UK, I was here in 2019, speaking in fact to Johnson Matthey, and looking at the build out of firstly your battery cell manufacturing capacity as it's planned, and then your electric vehicle industry on the back of that, you don't have the supply chain to support that growth. And the important point that comes out of our analysis, you are developing a local supply chain, but that supply chain is nowhere near large enough to support the growth in demand for critical raw materials, which ultimately find themselves in cathode active materials. So our business model begins with fast tracking the upstream integration and development of supply chains for critical raw materials from Western Australia. Western Australia is a politically stable jurisdiction. It can offer and does deliver transparent supplies of the critical raw materials required for electric vehicles. As I mentioned, we participate in the ownership, mining and processing of the mineral resources to secure long-term supplies of critical raw materials through acquisitions, joint ventures and off-take agreements. Looking at global chemical companies as we see them today, unless they own the metal in the ground, come 25, 26, there are major structural deficits in lithium and nickel emerging in global supply chains. And that hasn't, in our mind, been addressed by governments or for that matter by the industry itself. It's about scale. To build one 30 gigawatt hour per year battery cell manufacturing facility costs about 2 to 3 billion. It takes about 18 months. To supply that gigafactory with the critical raw materials in lithium, nickel, cobalt, manganese, if you're going for high energy density cathode active materials. Firstly, you've got to build a lithium mine. Then you build a nickel mine. Then you build a midstream. Then you build the cathode active materials plant. So to supply that gigafactory, you need $6 billion invested upstream and midstream. And again, the industry globally just hasn't put the investment into upstream and midstream. So that's what's coming out of our business model. For us, we launched the Australian Lithium Alliance earlier this year. It's a strategic initiative designed to partner with Australian companies to fund and fast-track exploration, mining, processing and production of lithium minerals. We see the bottleneck in the battery manufacturing business and electric vehicle industry as lithium, short term. So again, 25, 26 for us are pivots in the industry where we see growing structural deficits in supply of lithium and nickel in particular. So we, as a company, look to acquire the metal in the ground. We bring in a mining contractor. We'll design the process for the intermediate product, and from there it goes to midstream and downstream. We own 100% of the Range Well nickel cobalt resources in the Midwest region of Western Australia. They have approximately 2.2 million tonnes of nickel metal from surface to about 60 metres, about 150,000 tonnes of cobalt, thank you if you wouldn't mind, and about 700,000 tonnes of manganese. We are drilling out an area called Split Rocks, which is just 10 kilometres northwest of a project called Mount Holland, which SQM and Wesfarmers are currently taking into production to produce firstly a spodumene concentrate that feeds a lithium hydroxide monohydrate refinery. A very unique part of our business model is we're building the first integrated battery chemicals complex at Yanbu Industrial City in the Kingdom of Saudi Arabia. So we will take the intermediate product in the form of spodumene concentrate containing 6% lithium oxide, we call it SC6, into lithium hydroxide monohydrate plants. We propose to build or have planned 4 trains producing 25,000 tonnes of LHM a year. We currently have 2 trains halfway through feed, and we expect to start construction in the second quarter of 23. A sense of size, first 2 trains have a capex of 1.2 billion. In terms of project metrics, 165,000 tonnes of SC6 in, 25,000 tonnes of LHM out per train. NPV is about 2.3 billion. After tax, discount rate about 7%, IRR is about 32%. So we have 4 trains planned for that complex, and they'll be built between, we start construction in the back end of, start construction Q2 23. We'll be commissioning the first train in the first quarter of 25. The second train is staged behind the first train by 6 months. They'll be ramped up and at full production capacity by 26, back end of 26. We have 3 trains of nickel sulfate planned for the nickel chemicals plant. Those trains are each designed to produce 150,000 tonnes of nickel sulfate hexahydrate per annum. And we'll start the construction of the first nickel sulfate plant back end or first part of 26. In May 22, we had a great opportunity. We signed definitive agreements to acquire the global assets comprising the battery materials business of Johnson Matthey plc. The acquisition represented to us world-leading cathode active materials technology, pilot plants, laboratories, and battery technology centres. They were strategic for us. Firstly, The acquisition completes the integration of upstream and midstream supply chains with downstream customer-focused and facing cathode active materials business. There is no terminal market for lithium. And a lot of people we meet think these chemicals are commodities. They are not commodities. They are, if you like, pharmaceutical-grade chemicals. They are all different. There will be different recipes of cathode active materials, which you'll see from this slide. I mean, Johnson Matthey is an iconic chemicals and technology company. We're very proud to be associated with them, and we're privileged to have the opportunity to buy their assets. They have retained shareholding in our company, and we're delighted to have one of their senior executives join our board in due course. But the important point for us when we first started to bid on these assets were the people. I can't tell you how important it is to understand that technology is about people. It's quite often overlooked. With due respect to our finance director at the back of the room, although he understands his position, they're often seen as liabilities. They are not, number one. Number two, how do you bring to account 25 years of knowledge and experience acquired in developing technology? How do you put that on your balance sheet? You can't. You might buy it, then you have to work out what we do with an intangible called intellectual property rights. But they are so important. And we are very pleased to have had the opportunity to transfer 100 technical personnel from Johnson Matthey to our company. For us, the acquisition is strategic as well. It provides us with a platform for the industrialisation of the cathode active materials technology developed by Johnson Matthey in the UK for the UK with the very people that develop the technology. And from our research, around £750 million has been spent developing this. The industrialisation of this technology in the UK, in our view, is the first place to start to realise on that investment. So I've now visited all the sites. Billingham was the last one I visited. That was on Tuesday. And I can't tell you how humbling it is to meet the people, how incredibly they perform. They have high standards. They have performed exceptionally in terms of product quality. What a lot of people miss is cathode active materials is the end point for us as producing metals in the ground right through to what goes to an electric vehicle manufacturer or a battery cell manufacturer. They are customer-faced and customer-focused. The key is they are involved with product development. So it surprised me when I was at Oxford, state-of-the-art. Facility's about 2 years old. I haven't seen anything like it in the world. They can actually manufacture batteries, and do, to test the cathode active materials and the formulas, the recipes, if you like, that they've developed over the last 8 to 10 years. And JM were that close. Great opportunity for us. More importantly, great opportunity for the UK. So 7 cathode active materials processes, technologies, there are patents, there's know-how, there's show-how that we have the benefit of and now can move to commercialise and industrialise. Just a bit of background. This is data produced by the Advanced Propulsion Centre. I've got to say that Her Majesty's Government does a really good job in this area. The work, the thought, the research that is put into understanding where this industry heads, more importantly, where and what is required to develop your electric vehicle industry and your battery cell manufacturing industry. And this is particularly relevant for the Northeast. You've got, at least to my knowledge, 2 major gigafactories on the drawing board, if not ready for implementation. The British Volt at Bly, their capacity is reported somewhere between 30 and 50 gigawatt hours per year. Envision, I think is in Sunderland, if I've got that right. Excuse me. They're looking to build out 30, 40 gigawatt hours in 9 to 11 gigawatt hour per annum modules. So looking at this slide, it tells you, for example, that demand for cathode active materials in Europe has an extraordinary trajectory. The fundamental question is, where's it coming from? I can tell you now, the cathode active materials plants planned to supply that are insufficient in Europe. You've got massive build-out of gigafactories. I don't have the slide, but I think UK Innovate produced a report published earlier this week that shows you all the gigafactories planned. There's simply not enough cathode active materials plants to supply them. And if you're a new gigafactory and you don't have a supply chain, you spend $2 billion, yeah, for a business you can't produce product from because you don't have a supply chain. That's our challenge. Seriously. It's not just a UK issue or a European issue, it's a global issue. Then you step back and analyse the supply chains. Over 80% of global midstream and downstream processing capacity is in China. That's for these metals and minerals. Go to rare earth elements, it's almost 90%. And there are strategic weaknesses for Western economies having to rely on that position. A good example, Western Australia is the biggest spodumene producer in the world. I tried to buy 15 tonnes for test work a year ago, and I couldn't buy it. All of that is tied up under offtake agreements with Chinese chemical processing companies, hence the Australian Lithium Alliance. So we've got to be smart about how we develop resources and how we take them downstream and finally produce the product. Just after we completed the acquisition of JM's assets, I went home for a week of board meetings, and the board was feeling unloved and wanted to know the outcome. And we had a strategic planning session over 2 days. And what was interesting was we have to plan for resource nationalism and industrial nationalism. It's a reality. The assessment was given to us, said that we're not going to reset to globalization before the Russian and Ukraine conflict. Instead, we've got to look to and plan for geopolitical alignment of supply chains, which means alignment of national resources between countries that are geopolitically aligned. Similarly, industrial nationalism. For Australia, that means Japan, Australia, India, the UK, of course, and USA. This is not a political statement, it's a fact. We have to plan for aligning supply chains and in these future worlds. So looking at this, what is amazing about this is we don't think the cathode active materials processing capacity exists in Europe to supply this. So where will it come from? China. Then you've got rules of origin. This is really important. The UK has rules of origin coming into operation in 2027. We all have to get ready for that. It means that a certain percentage of what's in an electric vehicle and what's in a battery has to be made here, for that car to be sold here, or in that matter in Europe, vice versa. Europeans have set standards around battery passports, and into that comes things like battery recycling. But these are really strategic issues that as an industry we need to address and address now. Just taking that local, UK cathode active materials demand, this is where we're heading. We're heading, EV Metals Group is positioning itself and scheduling the development of our projects to supply this. So we look at companies in the supply chain in the United Kingdom. John, we'll write you an offtake agreement. No other company can do that. Why? We're a CAN producer. will be. Same for lithium carbonate, same for spodumene concentrate, the SC6. We've got to be in a position to offer offtake agreements as alternative to Chinese chemical processing companies. Otherwise, it just keeps going the same way. And you won't get that independence and geopolitical alignment that I think the world is looking for. I think, speaking to Julian Hetherington, who, by the way, heads your Automotive Transformation Fund and the Propulsion Centre, first class. I think he's suggesting there in that slide that by 2030, the UK requires 150,000 tonnes of cathode active materials. He's saying about 25% of that will be lithium iron phosphate, LFP. The balance will be high energy density cathode active materials, probably in the form of nickel, cobalt, manganese, 811, or variations on it. Johnson Matthey has developed the technology to produce all ranges, both at Oxford, Billingham, first-class facility, and I also visited Moosburg in Germany, where the company that Johnson Matthey bought pioneered LFP starting 20 years ago. Interestingly, I don't know where Tom is, but they've developed cathode active materials in the form of LFP for solar energy and wind energy. And the chemistry is about, someone said, what happens if there's too much wind? They shut down. Well, think about a battery. We didn't get to talk about the energy storage systems, but this is about how you store solar power, which has usually a neat curve. Wind powers can be far more intense, and you need cathode active materials that can store that energy rapidly without necessarily shutting them down. The future for us is sitting here. So the acquisition of the battery materials business of JM shifts the global focus and priority for EV metals to the United Kingdom and Europe. Our plans are to build and grow the battery technology centres at Billingham, Oxford and Moosburg for product development. There's R&D involved, but ultimately when JM sat down, and now we sit down with an electric vehicle manufacturer, you work with them to develop the specific cathode active material they require. And it's just not about chemical composition. Energy density and voltage is driven by morphology, how particle size, uniformity, shape, then how the architecture of that cathode active material is so important. This is world-class stuff, and we just delighted to be able to work with it. So, I've moved again. Really importantly, we need in rebuilding these facilities to bring in and create opportunities for what I call future jobs. These are for young people, that is, that come in and they're highly valued technical skills and positions. To pick up the know-how that's been developed to date, take it to the heads of younger people and allow them to take the technology forward. So another part of our acquisition, which we haven't quite completed yet, is Johnson Matthey's future battery technologies portfolio and their battery recycling technology, both of which are just outstanding. I'll carry on and just finish on this slide. Yeah. By the way, so the Northeast has a very strategic role to play as we go forward. Billingham is 45 minutes from here, or thereabouts, 50 minutes, getting my geography right. And it's designed, it produces CAM. So the obvious place to put a cathode active materials plant is right or very close to a battery cell manufacturing plant, which should be located close to an electric vehicle manufacturing plant. Thank you.
I'm sorry for buzzing, we're just very tight on time, and I wanted some people to have time to ask some questions, and that's okay. So if anyone wants to put their hand up and wants to ask a question, then the microphone will come.
John Walker from Tees Valley Lithium. Michael, and you probably saw me nodding throughout your entire presentation. It's great to finally meet someone that has a good understanding of the background narrative in the battery space. So I think really just from my perspective, and we have a very, very similar view on what's happening with the industry. You know, as you said, China's controlling 90% of the world's lithium resources and conversion facilities, etc. You know, in 2030, the 600,000 tons of lithium is going to be required by the gigafactories in Europe, and currently there's no production. So really just from my perspective, I think you could give my presentation this afternoon, but with your narrative, it's going to be that close. But really good to see what you're doing with Johnson Matthey's technology as well. And it's really, I mean, it'd be great to hear if you've got any plans to build, you know, a cathode active material plant in the northeast as well. So we'd be interested to.
Yeah, I didn't get to that. So we built the first CAM plant here. We're just working out what chemistry and where. It's not far from here. It's the obvious place. It's got to be close to a battery cell manufacturing plant. You know, there are two. As well, we'll finish the pilot plant, or the commercial plant they started in Kona. Johnson Matthey developed a brilliant piece of chemistry called eLNO, high nickel, high energy density cathode active material. It's in the Formula E car, if you know what that is. But Kona was built to produce that cathode active material. Some people say the plant was over-engineered. No. They designed that plant with incredible versatility. It can produce eLNO, any recipe of NCM. So it's a high nickel, high energy density cathode active materials plant. But thank you for your comments and look forward to your presentation. And I'll write an offtake agreement when you start producing.
Any other questions? Anybody else want to ask Michael questions? Well, thank you very much, Michael.